Alright, welcome. In this video we're going to fly through a canyon. We're going to populate this with a bunch of boulders along the sides. Then we're going to take a look at how we can use the camera map operator in TP to kind of activate and have those boulders break apart at a certain time. To do that, we're going to go ahead and we're going to render out a preview of this canyon as we fly through, and then we're going to take that into a compositing program and do a series of painted frames to control the activation map. So we'll begin with getting our TP in here, and then what we want to do is since we're going to start off with kind of some rocks along the side, there's going to be gravity involved and some shape collisions, so we're just going to go ahead and start off with a black box to get most of that stuff in there. We will use the SC basic, and sorry, we've got a lot of extra black boxes in here we need to clean up, but and instead of objects, we're going to rename this. This will be called rocks. And then we're going to have another group called force-bound, which is going to contain a group called frags. And those frags are going to be coming from the rocks. So actually, let's go ahead and call those rock frags. So our collision environment is going to go ahead and be the canyon. We'll pick that, set it to instance its shape, assign it to the collision environment group. We've got this set up on a layer here. So the ground layer there, we'll go ahead and hide that guy. And we also have a sources layer, which is this piece of geometry here, just a simple little geosphere that's going to act as our rock. We'll get that in just a second. But what we want to do, we're not going to actually create all those rocks in that fashion. What we're going to do instead is use particle draw, and we're going to draw on that source object of the canyon, so we actually need to show that again. And we'll disable that collision environment, just keep it from popping up. Check master dynamic, make sure that edit on the fly is turned on so that TP is not continuously trying to update. Remember, that's a little counterintuitive. When it's on, then you can make changes and not have it try to update. If you turn it off, that means, hey, I want you to update all the time. And of course, anytime you switch that, you have to scrub just to set it in that mode. Okay, but let's go ahead and get the particle draw. We're going to set the max painter, the count to 1, so it doesn't paint too many at once. That's a rate. The options, something important to know about max painter is that by default, this 0 point here is set to a value of 1, which means that when you paint, particles near the center of your brush are going to be higher than particles out here toward the edge of the brush. So we're going to go ahead and set that down to 0 so that it does not add that extra distance displacement on there. We don't need pressure sensitivity right now. We'll just go ahead then and we'll pick the object that we want to paint on. It gives us the brush. We're going to hold Shift and Control and click with our mouse and drag that down and make it a manageable size. Actually, let's go a little bit bigger. And we'll just go ahead, and you can see it's going to create a lot of particles here for us. We're not going to worry too much about that at the moment, except let's switch into wireframe mode. Because what we're going to do later is we're going to actually filter those out to kind of remove ones that are too close to each other. But what we do need to do is just kind of step through and paint certain areas. We're not going to go too crazy with the number of particles right now. Let's see if we can't get some more in there. We just want to make sure that we have enough to work with when it comes time to activate all these as we go through this shot. Almost there. Let's see if we get some in here. Okay, and then it's going to fly way up here. So we'll go ahead and stick a few more. We're going to have some breakout in here. We'll have a whole bunch along this edge. Okay, so another problem that we have is that we've got all these painted frames where the particles occur. and it shows us the frame number and then the count number of particles that have been painted on that frame. What we need to do is kind of condense all those so that they all actually start at 0. So a real easy way to do that is use the expanded time range, set that length to 0, go ahead and say all, and it's going to go ahead and condense them there. Okay, so now let's go ahead and get some properties on this these rocks of ours. We're going to go ahead and use a standard size shape. Don't really need the standard shape, we're going to just go straight for the geom instance, enable that. And let's go ahead and pick that object. We're going to be, the final render instance, that's only for rendering. Just by default we usually do check it since that's what we're usually using. And our size, we're going to go ahead and set this to 1 with 0, and we will, actually let's bring up our group manager. And remember, this is just an alternate way to manage group properties. It allows you to select multiple groups at once and set all their parameters at once. Okay, so now we get those rocks in there. The rocks themselves, the rock frags, let's go ahead and make them kind of an active color. And force bound, we don't need any color assignment there. Okay, so we have way too many particles overlapping, and this is even with the size of 1. Let's go ahead and turn our edit on the fly off so we can see these updates as we sculpt them. And bring these down quite a bit. Okay, so somewhere right around in here. So let's make another rule right after that born. And what we'll do is we'll have rocks at birth. We want them to look around, so we're going to use a p-search. That's the particle doing the searching. The group it's going to search for is in its same group, so we'll connect that group to the rocks particle. And we'll control when the p-search on occurs. We'll use the particle age to drive that. And so now the only parameter here we need to modify is this radius. And what we're going to do is have all the rocks at birth look around for other rocks, and if it finds a rock that is too close, then it's going to delete it. And the way that it's going to choose which one to delete is it's going to check their PIDs, and it's going to keep the lower PID, meaning the older or whichever particle was created first. So we'll do a little comparison here. M3D condition, black box, say less than. So we'll just take the PID of this and pump it into all the found PIDs. So it's going to say, hey, is my current rock less than each of the found PIDs? And if it is, then it's going to delete those found PIDs. And remember, it's going to iterate one at a time through each of those found PIDs. So let's go ahead and crank up our search radius. Let's see what kind of units that we're dealing with here. Let's go ahead and draw just a line and get some measurements out. So really only a distance of 4, so something is not going correctly here. Let's take a look. Let's go, and our particle draw, we forgot to set the group. Right now it was set to all, so let's set that to rocks. And so now we get a whole bunch of them disappear. That's a little not quite what we want. We need to bring more of those back, and you see as we bring this radius lower, it's going to allow more rock particles to be in these areas. Whoops, except we got 0. That's a little too low. Okay, so for what we're doing, this will be fine, except gravity's affecting them now right away. Let's go ahead and control that. Gravity, we only want to have affect the rock fragments, and the SC, we'll go ahead and disable that for right now. And so this particular rule that we just created, we'll call this filter out, and that would actually be a really good one to save as a black box. Just because that's a pretty common function to search around for other particles and remove the ones that you don't want. Okay, so something else we're going to do now is we're going to set up the camera map UV coordinates. And the way we'll do this is we will say all rocks are going to get camera map property applied to them. And the camera that we're going to use is actually going to be our shot camera, of course, which is going to be that camera 01. And actually camera map channel 1 is so common we don't really want to use that, so we're going to go ahead and switch and use number 10. And so what this will do is, because there's no conditions on the on for this camera map, there's nothing to control when that occurs, that means that this camera map coordinates are going to be applied to all of the box particles on every frame or every time sample. So as our camera moves through this canyon, these rock particles are getting new camera map coordinates applied to them each time. And so here's what we're going to do next. What we'll do is we will go ahead and create a preview. We'll do the full sequence, 100% size. We'll choose a custom file type, and we actually already had one that we had been testing there, so let's go ahead and say canyon sequence preview. Okay, so inside canyon preview, we'll just call this canyon preview. Save them out as JPEGs, doesn't have to be any particular big size. And so we can see a problem happen right there. We forgot that our lifespan on these particles is going to be a little too low, so let's go ahead and change that. Okay, let's try that again. And we'll save out as canyon preview again. Put you on pause for a moment. Okay, so that finished up. Now what we're going to do, you can paint this image sequence with any program that'll do it, whether it's Fusion, Nuke, After Effects, etc. In our particular case, we're going to go ahead and use Nuke. And we will set this up. Let's go ahead and grab our Canyon preview. Just drop that whole folder in here. And there is our lovely canyon sequence that we're going to go ahead and paint over. So let's go ahead and do that. Actually, first I want to check and look at the starting lineup based on our camera. Okay, so yeah, that looks all good. Let's go ahead then and add our Roto Paint node, where we're going to use a background. It's going to be that object. And then we'll take a look. What we're going to do is we'll go ahead and get in about, say, 8 frames. And remember, what we're going to be using this activation for, you can use it for all kinds of things. In our particular case, we're going to use it to cause volume break fragmenting on these objects. But you can do it anytime you need to activate a particle using this camera map technique. The one thing to remember if you do the camera map technique is that before you can apply the camera map, or before it will work, the objects actually have to have a shape assigned to them. So if we were to try to assign our camera mapping ahead of time, well then on this first frame what would happen is the rocks would try to get a camera map, but the rocks don't have any geometry yet because they have not been created on that first frame. And then in the next rule, the geometry gets created. But then every following frame, every sample afterward, then it would go ahead and get the camera map. But it would just be that first frame. So just remember, before you can use the camera map, make sure that your particles have a shape assigned to them. Otherwise, that camera map's not going to take effect. So let's go ahead, and what we'll do is paint a series of frames, and we'll just grab some simple stuff. This doesn't have to be anything super special at the moment, as you can tell by my painting method. And we'll just cover a bunch of these guys. We'll get this in here. Now one of the things that we're going to come to face is that our distance from our camera, we're going to have to put some kind of check in there, because if you think about it, we can actually, this painted frame that we encounter, say right here, this is actually going to be projected through, all the way through that canyon. And so the rocks on the far side are going to also be receiving this white activation map. So we're going to have to make sure that our activation range is controlled to some degree. We'll just put a little distance helper in there and control that. Okay, so I'm going to paint a bunch of these frames. I'm not going to bore you with all of that. And so we'll go ahead and put you on pause while I finish this up. Okay, so after some painting, we now have a whole bunch of activations. So you see all these little white blips that occur up on screen. What these are going to do is these are going to tell our particles, hey, your map threshold is now going to be this white on black. We're going to set a black background. And then that white portion is going to be detected on those particles, and it's going to cause them to, in our case, we're going to use it for the volume breaker activation map. So we kind of fly through this whole scene. It's a little bit sloppy. This isn't the obviously done in 5 minutes. But this is just kind of one of the methods that you can use inside TP using the camera map to have some artistically guided control if you have to have camera specific kind of activation occur. Okay, so let's go ahead and we'll get this. Oops, don't need a second one of those. Let's use a constant, and we will change our background. Actually, our project size is not quite correct. There we go. Okay, and then we'll go ahead and write these out. And let's go ahead and put that on our projects area. TP4 video, DVD, videos. This is the advanced section, topics, Canyon preview. And so then what we'll also have is a folder called Canyon mask. And so we'll call it Canyon mask dot, what is it, %04D, save them out as JPEGs. JPEG's just a nice, fast, small file format. And we'll go ahead and render these, and we'll be right back. Okay, it wraps that up, and we will go ahead now and jump back into Max. Open up our material editor, and we are going to grab that bitmap sequence, and then we'll set up the volume break. So we need a bitmap. We're going to pull it from here, our Canyon mask. It's going to be a file sequence. Right now we're lucky our frame range starts at 0, so our time starting is going to be 0. We are going to set that to hold at the end. And then our map channel, let's make sure that we don't screw this up, should be map channel 10. So we'll go ahead and punch that in there. Okay, so now we've got this this bitmap in place. It's an animated sequence. We'll go ahead and just kind of scrub along and watch it pop up our colors here. Oops, guess we can't do that. Okay, so that's all fine. Let's go ahead and get our volume break set up. And what we want to have happen is we want the rocks to undergo some volume breaking. So connect those. And our volume break, we'll set those parameters up. We want those to be, the fragments to be put into the rock frags group. Activation, we need to leave at 0% because that's actually going to be controlled by our map down here. Our master dynamic, I think, is probably still set to add on the fly is turned off, so it's trying to update all of our rock particles, which is going to be pretty expensive since it's going to have to subdivide all of those objects. So what we're going to do actually is we're going to put a little condition in place that's going to allow us, man, this is my keyboard controls out of control here. So what we're going to do is actually we'll disable this VB rule because it's eating up too much CPU at the moment. We're going to go ahead and measure from our camera about how far we want that camera activation map to occur, and so we use the line tool, and then we look down here in the status bar for that distance. So we want the distance to be about 30, 35. So that's going to limit how close these are to the camera before this is going to turn on, and we're going to set that up just like this. So we'll check the distance, the rock particle, with our node, which is our camera. And if it is within 0 and 30, then we will go ahead and allow that volume break to turn on. And once that turns on, then it's going to go ahead and subdivide that whole particle and kind of prepare it to be volume broken and those cells be activated. So we're going to go ahead and take our activation map. Let's call this Canyon Mask, just to keep our naming all clear. So we'll stick that right here in an instance of it in that map slot. The threshold, meaning it's going to be looking for in values, color values from black to white, so it'll take a medium gray or above in order to activate. And let's go ahead and our activation, we're going to set it to center negative, so it crumbles from the outside toward the inside. At least I'm pretty sure that's what that one is. We might have to switch that around. And then our volume breaker, we're not using the cells. Our raster, we'll leave this at the default for now. The material ID, will actually change that to 2. And I can't stress enough, and we'll talk about this more in some of the production topics, when you start doing volume breaking, make sure that you plan your materials for each particle who's going to be breaking, and make sure that you have a material ID specified for it. And if need be, what you might want to do is actually control that on a per particle basis. If you have a memory channel or a data channel that's keeping track of, hey, when I volume break, make sure that my my VB mat ID, is a custom number created maybe at birth or with a user-defined property, and then you can feed that in there in order to make sure that each one of those particles gets the correct mat ID. Because that can be pretty confusing on a multi-sub object with a lot of different objects who have different materials. If all of those object materials do not have the same mat ID number, then you're going to end up needing to control that manually like that. Okay, but enough of that. Let's go ahead, and the one thing that we really want to do is control the max number of chunks so that these things don't get out of control. We're going to go ahead and set that to 100. To keep them limited. And right now what we're going to do is we are going to save this file. We'll save it as start. We'll call this in progress. And then we'll go ahead and see what happens, because we think we may have found an unfortunate little bug where the camera map does not activate right away. One of the things that we want to do though also is have those volume broken particles do something right away, just so that we know they're being created. Let's stick a little velocity on them, shoot them up in the air. Okay, so let's check our map. Okay, so if by frame 8, on frame 8 we should get our first activation occurring right there in that middle section. And I don't know about you, but I don't see anything. So we're going to have to go ahead and, oops, well, it would probably help to enable that rule first. Brilliant. Okay, make sure this is still set up. Okay. Okay, yeah, so it's not appearing right away. So what we're going to do is we're going to go ahead and save this file and restart Max, because we think that once we do that, then this mask will go ahead and take effect. So we'll be right back. Okay, so the theory holds true. Looks like there is a small problem with that map, so you have to restart Max in order to have it occur. Let's go ahead and we'll kind of step through here and just look in this kind of middle section. You'll see that these rocks go from their orange default color into their fragment color, which is that yellow. So we can see those bursting right there, and over here we'll go ahead and turn on a wireframe to see that. Okay, so we're going to go ahead and also set up a little shape collision, but actually we are going to actually use PhysX in this case. PhysX has a nice option where it should allow us to handle the shell material of this ground that we've got. We're going to go ahead and check on our collision environment. We're going to tell the PhysX operator to treat this as a triangle mesh, which is going to be expensive in terms of simulation time, but it will read kind of the triangle accurate. We'll go ahead and drop our PhysX operator in here and go ahead and pull the SC basic. Let's go ahead and just rename this to SC. We'll go ahead and treat size as mass. And we'll use hardware because we have an NVIDIA card. Activate all because we want all particles to be considered. Oops. Yeah, you don't want to change your camera. That's a little dangerous. Let's go ahead and get in here and hopefully that did not get displaced. We'll set some locks on there. And our solver iteration, we want it to actually be more than 4. We kind of want some accuracy involved. So we'll go ahead and make that 120. Okay, we'll do a little, let's make sure, I think we had disabled our collision environment. And let's go ahead and get our layers. Turn off all of our layers except for TP. And see, okay, so we get everything showing up there, nice. And then we'll go ahead and record this. We're going to rename this, we'll call this Canyon. And to start, we'll go ahead and just cache out the SC basic portion. We'll do that on our specific TP cache directory. You can see some of our colorful names in there. And let's go ahead and we'll let this cook, and I will be right back. Okay, sorry about that. We found a little problem that we're going to have to correct. Apparently our video card's not set up for PhysX hardware, so we're going to leave that unchecked. We're going to set the skin width down to 0.01. 0.1 might work as well. We'll go ahead and set that back to the default. And then we will go ahead now and cache that out again properly. And something else, we actually added a shell extrusion onto that landscape. So we will go ahead and cache this, and we'll be right back. Okay, so we got enough frames that we can actually go ahead and kind of step through and check and see what's happening. And we'll go ahead and zoom out on this top view a little bit. So as our camera flies through, let's switch into this mode. So obviously our camera map is working, it's activating these guys. I'm seeing some interpenetration still, but we'll worry about that in a moment. Okay, so as we're flying through, yeah, we get this activation. One of the problems is that our fragments can fall all the way down to eternity, which is going to be kind of a pain if you're having to export these out. So one of the things we'll do is we'll use our mouse in the grid here, and we'll just notice that our Z height at this point is -10. We're going to put a little altitude check rule that says, hey, if these rock frags, if their position in Z is below -10, then just go ahead and freeze them. And that'll kind of hold them in place. It's a nice way to do it instead of actually telling them to use the particle die, because with particle die, then what'll happen is it will apply some opacity keys when you export, which isn't a big deal, but it's nice to have some scripts on hand to help manage those opacity keys too. Okay, so we'll do this, and we will add a rule that says if altitude, again, this will be for rocks, or actually, I'm sorry, not rocks, rock frags. We'll take their position, break that out into a 0.3. And of course, you know, there's a few different ways you can do this with TP. An expression operator is a really good way, but in this case, we'll just break it all out. And we'll do a threshold on the Z value. So if it is inside -10 down to -999, so it's going to be looking for this specific range. If that is the case, then we're going to go ahead and use a freeze rule on that particle. Control that and tell that to turn on when that threshold reads true. And we'll set that freezing factor to 100% or 100. Okay, and then actually I kind of want to see if we can get the physics to work a little bit faster. We're going to drop that solver iteration down. And from here, I think we are, we want to change the volume breaker. We don't want it to really launch up in the air so much, so we'll just kind of set it to this. And we do want to create a little bit of a gap in between those rock frags when they're born, so we'll just go ahead and use a scale operator on those rock frags when they're born. And we kind of find, or at least in my experience, that you can get away with about a 98-97% size change when something breaks and fragments. But if you go kind of below that, right around 96-95%, people kind of start to notice, hey, that just scaled down when you broke it. Okay, so let's kind of reorganize this stuff, make it a little bit cleaner. Camera map is there, gravity, our if altitude. Okay, let's go ahead and save, just to keep everything updated. And we're going to go ahead and cache this one more time, and we'll put you on hold for that since it's going to take a few moments. So we'll start it up and be right back. Okay, so let's take a look. 8 minutes, 44 seconds for simulation time. And so now what we have, we actually did something else kind of behind the scenes. We took off that shell just to see if PhysX would allow us to use that as a collision environment, and luckily it does, which is pretty nice. So here we've got, let's bring up our camera mask here. So as we fly through, we have all the different little activation painting portions occurring as we fly through our scene here. And then because we have that camera mapping being applied to those rocks, and then followed by volume breaker with the distance check for the camera to make sure the rocks are close enough to the camera, and then it allows that volume break to occur and uses the map that we had painted there, that activation map, in order to cause those particles to volume break. Okay, so we're going to save this out as our final or finished. And just so in case you want to kind of dissect it and check it out, the camera map is pretty easy. Just remember, in this particular case, we're using the camera map kind of as a camera-directed artistic control. And then, of course, you're going to have to do some painting onto those specific particles that you want to have activated. And just a little note, the The volume breaker allows that activation map to touch particular cells and kind of spread and activate the whole particle. That's a little bit different than if you end up using camera map with specific particles without the volume break, and you want to detect if there is a specific color being projected onto that particle. That's a little bit different. You end up having to use a surface position test and accessing that specific UVW channel, and then you need to let's see, where is it? It is the text map color. You take that UVW, you would take your text map color here, put an instance of it in there, and have our rocks check on their particle shape. We could test a specific UVW. You actually might want to iterate and check a few of them. And then you could actually detect and break out this color. Let's go ahead and do that. And then you could actually set a threshold for that value, and or whatever color that you wanted to detect for, and then cause something else to happen. So just kind of a different route using that camera mapping mask on there. So go ahead and remove those items, and again, so a little bit of procedural, terrain creation, rendering out a preview to get our kind of sequence that we then paint where we want things to happen at certain times, and then bring that back into here, and then use that mask in whatever way. In our case, it happened to be volume breaker, and use it on that using the map portion of it for activation. And then just setting up, certain collisions and altitude checks to kind of, let's check our altitude check, see if that actually worked. I kind of have a feeling it didn't, since those were going a little low there. Yeah, something went wrong. Rock frags. Get your, well, that's part of the problem. You want that position to actually be fed into the vector, excuse me, not into the Z value. So then that Z value now will be properly tested. So we're going to go ahead and save over this version, even though our original sim there didn't do so hot. But that'll be the correct method. And then just it allows you to kind of control things through the camera, and because of the camera map operator being applied to those rock particles every single time sample, we're able to go ahead and kind of touch that UV channel and do something with it. So, okay, we're going to save this out, and we're going to go ahead and move on.